Okay, so hello all. In today's session, we'll be looking at KNN algorithm, which stands for K nearest neighbors. It's an algorithm which is used for classification. It comes under main our course on Introduction to Machine Learning, right? It is the fourth algorithm that we'll be studying. Right. So I have a picture here, which kinds of is taken from Facebook from a meme, which says, "Can and be like, show me your friends, and I'll tell you who you are." So basically, this picture is the complete gist of this algorithm, right? So K nearest neighbors means, to put in simple terms, any object or any person belongs to the class based on their neighbors, right? So if all the if you think of a real life example, so if you live somewhere, you spend your time in office, you spend your time with friends and all, so you have a specific group. So neighbors, not in terms of the person who is just living in the house beside your house, but it is like the top 5 or 10 or 3 or 4 people you spend most of your time with, right? So in generally, like psychology wise, your perception, your thought process, and your way of thinking can be summarized or is almost equal to the average of the top 5 person you spend most of your time with. Okay, so if you have very close friends, and so suppose you spend your time with your wife and you have 3 more very close friends, so the kinds of approach, that thinking process they are having, so your thinking process and your approach towards life or anything will be somewhat very close to their way of thinking. This is the gist of K nearest neighbors. So if I can identify the neighbors of any particular person or any particular data point, I can classify that based on their neighbors classes, right? Uh, so suppose we have an example where let me just switch over to yeah, let me just switch over to so this is the machine learning playground website. We also saw this website during the introduction or the demo lecture, right? So here I'll be just plotting some points. Suppose I want to study about I'm a veterinary doctor. I'm studying about animals, right? Four-legged animals like dogs and horses. So mainly dogs and horses.
Sir, the slides are not moving.
Visible, sir.
Slides are not visible. I think I shared my complete screen. It should be visible. So I'm on
slides
this
are not
website.
moving, sir. Yeah.
So I am actually I am on Chrome. Okay. So I'm on the website. I'm on this machine learning playground website. I'm presenting that right now. Are you able to see that?
Yes, sir. Yes, sir.
Yes, sir. Now we are able to.
Yes. Okay. So maybe some problem with the internet. So presently, I'm a veterinary doctor. I want to study about some animals, right? I'm particularly studying their heights and weights. Okay, height of animal on the x-axis and weight of animal on the y-axis. I'm studying. I know I have collected data from a known source, which looks like this. So these orange points are the dogs, and these purple points are the horses, because we know that horses have more height and they have more weight compared to a dog. So based on the logic, we know that most of the animals which lie on this side or the upper right side of this plot will be a horse, and animals which lie to the lower left corner of the plot will be more likely they will be a dog. Okay, now I want to make a machine learning algorithm based on the K nearest neighbors algorithm, or based on the neighbors of any data point. I wanted to judge or identify the class of any unknown animal. Suppose a new animal comes somewhere here at the center, right? His height, the animal's height and weight lies at this particular location. Now I want to identify which class I should put this animal in, whether this animal is a dog or whether this animal is a horse. So if a point is lying over here, it's very simple, right? I can see clearly that there is no dog in this vicinity. All of the neighbors are horses. So this point will be a horse. This animal will be a horse. If a point lies somewhere over here, it is very clear that it can be a dog or a pup. or a puppy or a small dog, because the height is very less and the weight is also very less. So I want to, but the actual problem lies at this intersection region where we have a very huge and a very heavy dog and a kind of a very thin and short horse, right? So this is the region of confusion that we may face. So suppose that animal lies over here, how can I identify which class it should belong to? Right. So let me take an example of k nearest neighbors, and I am k nearest neighbors. I am taking k is equal to 3. That means I will take the nearest 3 neighbors of the unknown data point, and based on those 3 neighbors in which the class belong, I will put my new animal in that class, right? So suppose my point lies over here, I'll take the 3 nearest neighbors, 3. So maybe this point can come, and this point can come, and this point can come. So out of 3, I have 2 horses and 1 dog. So I have horses in majority. So I will identify this particular animal or the new data point as a horse, right? So let's train it. So this is my boundary looks like, right? So I can change this number to be 5. Then I train it again. So I will get a boundary like this. If I make it 10, then my boundary will become more smooth, right? As I increase the number of neighbors, it will become more smooth. Okay, like this. So let me take it a higher number as say 30 neighbors, right? And I train, so I get a much clearer boundary, much smoother line. And I have some misclassifications, of course, because this dog is very huge in size, and it's very heavy, probably some German Shepherd or some Siberian Husky, something like that, which is almost so the most of the neighbors of this point are actually horses, right? All these 5, 7, or multiple points that we see are horses. Okay, so based on this, we get some misclassifications also, right? So basically, based on the neighbors, based on certain number of neighbors, where my neighbors belong into which class, I will put my data point to that particular class, right? Just like the example of a person. Like, so if you go to a school, you find people, students are running here and there, playing all over the school during the recess interval, right? And they are always moving in groups. So you can actually identify them based on their group. Okay, it's a group of 5 or 10 friends. One of the friends is missing, so you can ask where is he. Or based on, so if the group, most of them likes Salman Khan, or they're a fan of Sachin Tendulkar or Mumbai Indians, so it's highly probable that a majority of the people in that group will be liking that particular team only, right? So this is the basic idea, where I will classify any new data point based on the name, based on its neighbors, known neighbors, right? So let's take an example again, right? It's the same example. Suppose the red data points are the horses and the blue points are dogs, right? I have these 3 new animals, this green dot, this green dot, and this green dot, and I want to identify in which class I should put them, right? So this point is pretty clear. It is logical to say that this is going to be a horse with a higher probability. This animal is going to be a dog with a very high probability. But we are concerned about this point because we cannot judge based on with just this picture, right? So we want to have some kind of a mathematical or a formula or a systematic approach in deciding which class. So whether this new animal which is lying at the center, whether it's a dog or a horse, right? Let me just change the settings of my, yeah, it is now changed. Okay, right. So now, okay, let me share back again. Okay, so now what are the steps that need to be followed, right? So first of all, we need to store all the data, because anyway we need to process all the data based using a computer, right, or a cloud service, whatever. Then we have to run the prediction algorithm. So what is my prediction algorithm? It's very simple. I will calculate the distance from X to all the points in your data. So this X is the new data point, right? New data point, right? So I will find the distance of my new data point from all the data points in my class. Then I will sort the points in your data by increasing distance from X. So basically, suppose I already have 10 points. So my data maybe looks like this, right? And they all belong to some other classes. Like, so I have just to differentiate the classes, I have squares and rectangles. Okay, and I have suppose this new data point. I want to say that I want to identify whether this X is going to be a circle or it's going to be a square, or like in which class it should belong to. So what I will do, I will figure out the distances of X from all the points, right? So I will take the distance of X from all the points, sort them in an increasing order, right? So maybe like this is the closest, the next is this one, the third one is this one, and the fourth one is can be this one. I will arrange, I will create a sorted list of all the distances, right? And then I'll predict the majority of label of the k closest points, right? So I have say 10 points. So in my distances, I will have what? Increasing order of distance. So one is 1 centimeter away, or any unit 2 centimeter away, 2.5 centimeter away. Like this, I will have 10 data points, right? 10 distances. So I will pick top 3. I will check what is their class. So suppose this point is a square, this point is a circle, this point is also a circle, this point is also a circle, the fourth one also. So I found out that the 4 closest point, out of the 4 closest point, the 3 points belong to the circle class. That means my X point should also belong to the circle class. That's a simple funda of k nearest neighbors. Figure out the distances from all the data points, maybe sort them, or just pick the nearest, pick the closest k points. Now k is totally up to us, whatever we want to. So I can keep k value of k as 1, 2, 3, 4, 5, 10, whatever I want, right? So now choosing a k will affect the class a new point is assigned to. How? So basically the class in which I want to put my new data point to will be affected by the number of neighbors, right? So suppose I am talking about 5 neighbors. Out of 5 neighbors, 3 of them likes Mumbai Indians, 2 of them likes this Delhi Daredevils, right? So I will say, okay, you are also, because if you want to become a friend, our friend, you want to join our group, you have to go with the majority. You will also have to like Mumbai Indians. Now the same person goes to a bigger group of say 10 people. Now out of the 10 people, 6 of them likes Delhi Daredevils, but 4 of them like Mumbai Indians. Now situation has changed, right? But just because I have increased the number of people of the group, and I'm taking into account, right? So for example, take a look at this picture. So this red star is my new data point. I have a distribution of points looking like this. So I have a class A, which is in the yellow color. I have a class B, which is in the purple color. So class A, class B can be anything. Some like dogs and horses, whether cats and dogs, whether this thing you can take them as so whether they have corona or they do not have corona. Any two class, any classification problem you can pick, right? And X1 and X2 are the features. So they can be heights and weight. They can be some medical history. So whether or some, it can be like some time and other parameter, right? So any two parameter or features, I'm plotting them in a 2-dimensional plot, right? They have 2 classes. Now I want to identify where this star belongs to. This red star should belong to which class. I want to figure out based on k nearest neighbors, right? So if I set the value of k is equal to 3, so these are the 3 closest neighbors of this new data point. Based on the votes, I should say that now my red star should belong to the purple class, right? But now if I keep the value of k to be 6, then the situation completely changes, right? So the nearest 6 are these, and out of 6, 4 of them belong to the class A or the yellow class. So now my red belongs to the yellow class, right? So we always have to keep in mind or like we have to use our domain knowledge or some kind of a reference or some kind of information to decide on a value of k, right? So these plots show you some, so you can think of the same plot which we saw on the website, right? So this is horse versus dogs data, and presently the k of value over here is 1. So when the value of k is over here is 1, so I get a decision boundary like this. So these all points are horses, these are dogs, and there is a certain circular region, because I'm just looking at one neighbor, right? So it can be very confusing, right? If you're just taking into account the consideration of one of the neighbors, then you might there is always a chance of misclassification. Think of it as you have to buy a new laptop, right? So you did your own research, then you asked your friend. So you asked one of your friends only. So you're one of your friend who is kind of who reads a lot of books and all, whatever, just one person, and he said, bro, you buy HP laptop, okay, and you go on and buy that laptop. But so there is a probability that that laptop is going to be good or not. But if you ask 5 of 10, 7 of your friends, right, most like some of them can be gamers, some of the friends are from CS background, they do a lot of programming, and you take their opinion, bro, this is my budget, please suggest me a laptop. So maybe some of them can say go for HP, some of them can say go for Lenovo. So what you can do is that you can just take a vote. Okay, so out of 5 friends, 3 of them are saying go for Lenovo, 2 of them are saying go for HP, you go for Lenovo based on the votes, right? So it's always good to have at least more than one votes, more than one members, so that you can make a better decision, right? So similarly here, if I increase the value of K, I get somewhat a different decision boundary. Decision boundary somewhat means like decision classification, right? So previously all these points over here were classified as dogs, but as horses, right? But when I increase the value of K, these points got classified as dogs, which were the correct answers, right? Then if I increase the value of K further, then I get a very smooth or very clear decision boundary, right? So this is how the value of K or the number of neighbors you are taking into account affects your classification, right? So now what are some pros and cons? So pros are, it's very simple. Mathematically also, it's very simple. Training is trivial. So training is nothing but calculating distances, sorting the distances, picking up the top K data points or top K neighbors, right? Whatever the value of K is. And it can work with any number of classes. So suppose instead of 2, you have multiple classes, say 5 classes. So you will just take the top, suppose the value of K is 10 and the classes that I have is what, 5. So I will take the top 10 neighbors, and I will check their classes, right? So out of these 10, maybe 3 belong to class 1, 3 belong to class 2, and 4 belong to class 3. So it's, I will kind of put my object in class 3, and none of them belong to class 4 or 5. There are 5 classes, no? So I can just pick up the highest voted class. Okay, then it's easy to add more data. So like it is not taking, so it is not kind of doing any kind of manipulation with that original data. So I can just keep on adding. So suppose today I have 500 examples on which I am doing K nearest neighbors. Tomorrow I get again more 500 examples. I can directly add them to my previous model without doing any changes. It's so I can actually make KNN, make use of KNN on a real data or a real-time data which is coming from internet, or it is a live data based on some suppose you want to do it in sports analytics. So based on the performance of countries in Olympics, you want to do something or something, you can do that. Then there are very few parameters. So this model, this concept of KNN itself has very less parameters, right? So there is basically 2 parameters. One is what should be the value of K, and second is what is my distance metric. Distance metric is what? So what kind of distance I am taking. So the normal distance that we are studying here is the mathematical distance between 2 points, under root of x2 minus x1 whole square plus y2 minus y1 whole square. Simple, right? This is called Euclidean distance. And what are the cons? The high prediction cost. So basically high prediction cost. Why? Because to make a prediction for every point, it has to find the distance from every other point, right? Unless, so that's the only, because we have eyes, we can plot the data and I can see what are the nearest points. But for a algorithm to do it programmatically, it has to find a distance from all the points, right? Then it will sort all the distances. Then it will pick the top 3, top 10, top 20, whatever the value of K is. So it becomes the prediction cost. That means the computation cost is very high. So if my data set contains 5 lakh, 10 lakh or 1 crore rows, it will become more slow, right? And it is not good with high dimensional data. So presently we were in the previous slide, we saw saw a plot of 2-dimensional data. So once I increase the dimensions, then it becomes problematic to handle or to measure distances, right? And categorical features don't work well. Basically, it is why categorical features means okay. Categorical feature means some like good, bad, poor, or something like male or female. So we have already seen it before, that we have to encode our data, categorical data, or that string or textual data as integers, because it is finding distance. It is totally mathematical calculation. So it cannot find a distance between a female and a male, because male and female are English. We have to convert it into integers, maybe 0, 1, one short encoding, or one multi-hot encoding. We can use that. Okay, so basically just an overview again of the same concept. So this is this is a situation before KNN. I have my data points with two classes only, because one is the red class, one is the green class. There is a new gray data point that comes in. I want to classify this to either fall in the red category or in the green category. So after using KNN, I'm able to do this based on the number of neighbors that I choose, right? So it looks like it is more close to the red class. So if I even take 2, 3, 4, or 5 nearest neighbors, it will still fall into the red class, right? Now, what are the steps? So basically, you have to choose a number of k neighbors, first of all, because how many neighbors are we taking into account? Then take the k nearest neighbors of the new data point according to the Euclidean distance. So this is a distance metric we are using. So basically, find the distance of the new point from all the points, and you pick the top 5 or top whatever the k value you have decided. That many neighbors you take out a vote. Among these k neighbors, count the number of data points in each category. So basically, out of these 5 neighbors, you count how many of them fall into category 1, how many of them fall into category 2, 3, 4, 5, like that, and you take a note of the count. Right, assign the new data point to the category where you counted the most neighbors. So basically, in out of those k neighbors, so there will be a major, so all these neighbors will be belonging to some class or the other, right? So you take the maximum of the class that your neighbors belong to, right? Suppose your neighbors belong to class 2, more than 50% of the neighbors belong to class 2. That means your new data point should also belong to class 2 or category 2, right? So just how this algorithm works in action is that, so basically this is the this is how my data looks like, right? I choose a number of k of neighbors, right? So I fix the value at 5. Now I will go ahead. Basically, how we are finding the distance is this formula, right? 2 points, x1, y1, x2, y2. The distance between these 2 points is x2 minus x1 whole square plus y2 minus y1 whole square, right? Simple Pythagoras theorem. So this distance is what? Y2 minus y1. And this distance is what? X2 minus x1. X2 minus x1. I want to find this distance. So based on Pythagoras theorem, this distance will be what? Square of this plus square of this, right? And under root of that. So we know now hypotenuse square is equal to perpendicular square plus base square. This is perpendicular, this is base, right? So and if I want to find h, it will become under root of perpendicular square and base square. So perpendicular is this, my base is this, right? Simple, this funda, all of you must be knowing it. Okay. And yeah, same thing. So basically in mathematics, we studied about x-axis and y-axis. Here also we are plotting, but the unit is not in centimeter or meter. It can be in anything, right? Based on my data features. Okay. So if it becomes n-dimensional data, so presently it is 2-dimensional, so I have x2 minus x1 square, y2 minus y1 square. Now suppose if for n-dimensional space, x coordinate becomes x1, x2, x3 up to xn, because there are n dimensions, and also y coordinates will have y dimensions. So my distance formula will become like this. Same, just Pythagoras theorem applied to multi-dimensional data. And basically there are other distances which are called Manhattan distances, and some other distances also, but among them Euclidean distance is the most commonly used distance metric. So this Manhattan distance is distance in terms of, so between these 2 points, Manhattan distance is this plus this plus this. So basically this distance is Manhattan distance. So we do not, so in Manhattan distance you are not allowed to move in diagonals. Either you can go up or right, like forward, left, right, or forward. So only these 4 directions you can go, right? So basically for any 2 points, distance will be what? This plus this plus this plus this or this. So for Manhattan, this will be my distance, this line plus this line. There is no concept of hypotenuse there, right? So the third step is, among these k neighbors, count the number of data points in each category. So I took the 5 nearest neighbors, 3 of them belong to the category 1, 2 of them belong to the category 2, Now I will take the maximum. So assign the new data point to the category where you counted the most neighbors. So we counted the most neighbors in category 3. That means, so in category 1, sorry. So that means my new data point belongs to the category 1, which is the red class. Okay, so this is it. Thanks a lot. If you have any doubt, you can ask right now. Otherwise, I'll start probably a new meeting where I'll show you how to implement the same thing in using Python. Okay. So let me stop recording.